Okay, now after the reactance, let's come to the phasor. Okay, phasor. Okay, remember we did this one in the simple harmonic motion. Okay, and what does phasor mean? Okay, phasor means it is a rotating vector. So it is a vector and it is rotating. Okay, and we can turn the reference circle and we rotate this phasor in the anti-clockwise way. Okay, in the anti-clockwise direction, and then we can draw what? We can draw a sine wave. Remember that one? Okay, so this is a phasor. And let's see how we use phasor into our AC circuit. Okay, so RC first. RC, this is at page 333. Okay, so if this is VR, okay, if this is VR, and what is VC means? Okay, so we have a power supply, and we have a R, and we have a C. Okay, so a resistor and capacitor. Okay, so we put the two voltage here, voltage VR, and another voltmeter here, which is VC, and of course we can put a current, which is I there. Okay, so we can know the value of like every moment. Okay, and then phasor, so this is VR. Okay, and then from here is 0. Okay, and then start to rotate it to here, and then it's maximum 90 degree. Okay, 80 degree, that comes to here, then 270, that comes to here, and then they come back to where it is. So this is one cycle. Okay, so this is phasor. Okay, and do you remember we talk about ICE? Okay, ICE. Okay, and I is current. Okay, and current, they are in phase with resistors. Am I right? Okay, so for current, for this E, this is VC. Okay, and this is VR. Okay, for capacitor, the voltage lag by 90 degree. Okay, so that means when VR is here and this is our rotating direction, so behind or lag 90 degrees where is here, is in this direction, so this will be VC. So when VR is 0, this will be like a negative maxima or -1. Okay, so let's start to rotate from here to here, that comes to 0, and then it goes to maxima here. Okay, so this is how we draw the phasor diagram for RC. Okay, and now we can check another thing. Okay, so we have what values? We have I, okay, and we have omega C, XC, reactance of capacitor, and R. And you know from Ohm's law, V equals to IR. Okay, and if we describe the reactance in AC, then we can apply. That's why we want to use this one, VC, like Ohm's law, like IR, IXC. Okay, this is the advantage of applying reactance, because we can apply the Ohm's law. Okay, remember this one. Okay, it's a very important advantage. Okay, so in this one, if we combine these two, diagram together, here is our VC. Okay, VR, sorry, and here is our VC. Okay, and then we can add them together. What does that mean? I think you know R and C, resistor and capacitor, they are in series. Am I right? SERES. From a very basic DC idea, if I got two elements here, they are in series. Okay, so this is the VC source. Okay, and here I got V1, and here I got V2. When they are in series, we can have like VS equals to V1 plus V2. Am I right? In DC. Okay, and in AC is the same. They are in series, so VS, okay, like here, will equals to what? VR plus VC, because they are in series. but the difference now is they are not like just numbers. Okay, they are changing directions. So when we add them together, we should add a phasor. So it's phasor. Okay, and you know phasor is a vector. So you are adding vector together. Okay, vectors together. You're adding vectors together. And how do we do that? Okay, vector addition. We are adding them together. Okay, so if this is VR and this is VC, and how do we get this one? V equals to IR, and VC equals to IXC. Okay, so how do we add them together? They are vectors. So this is VR, and this is what? This is VC. Okay, so the V source is what? This is our VS, V source, the total voltage power supply. You can say it's the, you can say it is the, okay, I draw probably one more time. So this is our AC, and this resistor and capacitor. Okay, you can say it's VR plus VS, and this is VS. So the voltage here will be the voltage here. They are the same, or the total voltage. Okay, and that's how we add them together. Okay, similarly, when you remember RL, this is at page 339. When we do about RL, okay, RL is 80 ELI for inductor, the voltage lead. Okay, so if this will be our, if this is our VR, okay, and then here this will be our VL, because VL voltage lead the current, and current is in phase with voltage across resistor. Okay, so this is how we draw it. Of course, again from 0 to maxima. Okay, but this one is the maxima already, and then they decrease to 0. Okay, and then again, this is how we add them together. Okay, so VL is here. Okay, and VR is here. Okay, Pythagoras, and we can do what? We can do VS equals to VR square plus VL square. Probably write VR here. Okay, and VS is VL square plus VR square, and take the square root, Pythagoras. Okay, and another thing we need to know is like if we can ask you the source is lead VR for how many degree, theta is how many degree, and you know this will be in tangent. Am I right? So arctangent VL, opposite is VL. This is opposite. Okay, and over VR, over VR. Okay, and similarly, I didn't do it here, but we can do it here as well. And what is the angle for this one? Okay, the angle for this one, opposite here, opposite is VC, so theta will be arctangent VC over VR. Okay, the angle is here. Probably highlight this one, and the theta is here. Okay, so this is the phasor for RL and RC. Okay, another thing we can say, phasor make the calculation much easier. If you see here, okay, we know VS equals to VR plus VC. Am I right? Because they are in series. Okay, so this is my VR. This for okay, say for this moment. Okay, this is the value of VR, positive like something, and VC is here, negative something. Okay, so VR, okay, and minus, this is this is VC, and if I put this one to here, this is actually VC. Okay, and then VS plus VR becomes to this one. Does that make sense to you? So it's actually, because VR is positive and VC is negative, so when VR plus VC, it drops from here to here. So I can take it and do it one more time. Okay, so VR is here positive, that much. Okay, and VC is negative that much. Okay, so the result is that much. This is VR plus VC. I hope it makes sense. Okay, similarly in the V for the inductor, they are the same. So the moment of VR is here. So this is the VR. Okay, and VL is how much? Same number. Okay, VL is that much. So you can move this one to here. When you add them together, okay, so VS is VR plus VL as well. Okay, but the factor, the phasor diagram make the numbers, work out the numbers much easier just by Pythagoras. Okay, I hope this makes sense, and we will do one question later.